So I'm Mohamed Bejijou, so I'm from Valeo. I'm responsible for new software technology and architecture, and thank you for giving me this opportunity to present the software as product topic. So in this presentation, I will present how software is becoming a product in the era of the software-defined vehicle, with a focus on some challenges impacting the software in development and in operation. So as we have seen, to achieve the automotive market megatrends known as ECS, or as presented this morning by Thomas like case, to have automated, connected, and electrical vehicles, and to enable new services and business opportunities, we had to simplify the EE architecture to move from a highly distributed to a centralized one with domain, zonal, and high-performance computers. And this led to an increase of complexity, which is a fact today. Complexity of the processing units and the associated software, plus the system and software integration. And this is the only visible part, and the objective of this presentation is to focus on other challenges that we see. Beside classical and adaptive AutoSAR, we have to use additional or new software frameworks not initially designed for automotive applications with new technologies. With new technologies like we have seen hypervisors, containers, new protocols, and to achieve, we still need to achieve the safety and the real-time aspects required by our automotive applications. And on top of that, we still need to keep the software requirement for as software decoupling, hardware-software decoupling. The next topic is about the extended software lifecycle, as maintenance today is not only to fix issues, we need to evolve the software content also. On top of that, we have additional requirements for cybersecurity, for software update coming from new regulations. This comes also with new collaboration models where with multiple partners contributing with or supplying this software for the same high-performance computer or complex ECUs, which lead to new constraints and challenges in the system software integration and the DevSecOps tool. Before speaking about the new business challenges, let's have a look why the software is becoming a product. We are moving from a scenario where software, what I mean by software, basic software, application software, delivered inside an ECU plus its associated sensors and actuators, to scenarios where we can deliver only software plus sensors and actuators, and we have today scenarios where we have to deliver only software. So now we see why we speak about software as a product. As I said, we have many challenges, and for this presentation, I will focus mainly on the challenges coming from the impact of software multi-sourcing. The second impact will be about challenges for multi-partners integration. And the third one will be linked to the software product lifecycle, and especially for the software product tracking. So in this slide, we see the evolution of the software architecture, where software functions are moving more to high-performance computer. on top of a middleware, which is today not standardized, which lead to proprietary and specific implementation to cope with the multi-operating systems that we may have. Beside classical and adaptive AutoSAR, we have RTOS, we have Linux, we have Android, we have the use or not of hypervisors, and as we have seen, the new technologies to enable containers, to benefit from the use of the capacities and capabilities of the new processing units, like accelerators, specific engines for EI, etc. And as you see here, each part is delivered from, in this new model, from a specific supplier at a larger scale with a big amount of software, where we have less interoperability, and we will have a dedicated focus on system and software integration. And what makes things complex more than what we have seen with the well-established methodology with AutoSAR. So thanks to the job done by AutoSAR the last 20 years, so the initial objectives of AutoSAR since the beginning was to achieve the abstraction, to enable automation of the software build and the software cooperation and collaboration between the partners for the same ECU. And for the whole car methodology, thanks to the VFB view, since the beginning, we have mechanism to develop agnostic functions. Here I mean by agnostic, mechanisms to abstract not only the hardware, so to abstract the vehicle topology, the network, the different protocols, the ECU, and the used microcontroller. And I believe today, as you said, most of the cars, they have AutoSAR, and I believe most of you have experience where from projects you move a layer, an M-car to another, you change an operating system from one provider to another provider, and thanks to what was done in the past, this demonstrated how this is possible if it's well designed before. It was not only a matter of abstraction, it was also a matter of methodology. So AutoSAR released the needed templates for both classical and adaptive that helped especially the tooling providers to establish a mechanism to help for example, either for application to have a common software description, and for basic software to exchange the configuration and to enable further automation to provide more efficiency in the build system. And as it was presented for both classical and adaptive, a layered software architecture that contributed also to this abstraction. And on top of this, the continuous cooperation to extend AutoSAR. So since the beginning, to cover the different, I would say, requirements from ISO, the cooperation with ASAM, and now with Covisa and Eclipse from SDV. But as we have seen in the previous automotive open conference, so this was presented by Vector, by Marcus, AutoSAR is a part, I would say, it's a part of the big picture to achieve the SDV. And now the objective is to see how to extend, to define a kind of common methodology, because to build an HPC is not only a matter of AutoSAR, either classical or adaptive. So it's now, it's a larger scale. So the work done and ongoing with Covisa is, I believe it will contribute and help for the common API, but we need a methodology to simplify and to ease the system and software integrators, as we have seen with these multiple suppliers, this will be an enabler to have efficient configuration. Otherwise, it's not a matter of the future because we live it today. Everybody is doing its own implementation and specific one. And the problem is that in the future, we will provide bigger effort to harmonize it. The next challenge is about the partners' relationship. We are moving from a model where it was, I don't know if it was simple or not, but at least it was straightforward between an OEM and Tier 1, managing the different connection with the semi-supplier and the different software suppliers, and where the ECU was integrated by the Tier 1 to a model here I'm speaking mainly about the high performance and complex ECUs, where we see today that OEM is mainly connected with the hardware supplier, which is probably or most probably different from the Tier 1 or the other software suppliers, and where the system integrator is not necessarily the Tier 1 as we had in the past. It can be even done by a fabless company, not a classical Tier 1 or classical Tier 2 that we had in the past. Then to move to a scenario where to enable even direct interaction between the software suppliers and the end user, thanks to, like we have in smartphones, thanks to App Store's mechanisms. You can imagine the complexity for task for the system integrator during the development and after the deployment or the production of the vehicle. Here we understood that to build HPCs, we have plenty of suppliers. We have software coming from the OEM, from competitors, from multiple partners, and there will be one integrator of this complex system. And in this example, we show a mechanism, or let's say a tool. It's an integration portal that we developed in our software factory because our daily task was to manage the diversity of the inputs because we don't have a common methodology in these new complex architectures. And thanks to this portal, the idea is on how to increase the efficiency and the productivity in our daily job, and this to enable each partner to be autonomous somehow, meaning that once you deliver the final package, you will make sure that you pass the quality gates for the build, for the analysis, for the software test, for the virtual test, and you can add as many quality gates as you want. So again, here it's a specific implementation. So the problems that we faced because of a lack of common delivery package description, for example, because we will go to another project with other partners, so we need to develop another specific solution. So here, an extension of the methodology can help to define some package description, or like we have in other industries, like a manifest description, that can be used to automate the activities that we have seen here. We have seen that now the development will move more and more to a cloud-like development that I believe will simplify, I hope, a lot of the problems that we have today, especially for the different development environment that we have. I believe you all had experience where you receive a package which is green from the supplier. When I say supplier here, a partner. And you check it on your side, and it's not behaving the same way. And this is, I believe, will be solved with the new type of tools. In automotive also, we are missing an SDK. If you look to smartphone industry, either for Android or for iOS, you start to develop an app, you download a ready SDK, where you have everything integrated in the IDE, from editing till deploying and even emulating and deploying directly your application to inside when I say smartphone, it can be a tablet or a target hardware. Yeah, the next challenge is about the extended software product lifecycle in automotive. As today, SOP is not the V1.0 of the software. Here it's a comparison between the lifecycle, I would say the traditional one, where the development, here I mean by purchase, when a user purchases a car, or let's say, or at SOP, the development cycle was from 2 to 5 years, depending on the products. And the maintenance was from 10 to 15 years, and it was mainly to fix the issues or to provide some enhancement. And the user experience was static, meaning that you buy your car, you have your software, and you have it till the end of life of the car. With the new life cycle, we have a shorter development cycle with shorter deliveries and even more frequent. And after SOP here, SOP start of, I mean by SOP start of production, the car is connected, so we have to benefit from this capability, so to provide not only fixes, but we can enhance and evolve the content, and to the user can enable new functions thanks to that. Meaning that for the software product, we have a longer maintenance period. On top of that, as I said, we have new regulations coming with new requirements, not only for the product, but also for the infrastructure. And here we will need for new technical mechanisms to implement not only in the car, but also in the infrastructure, and most probably also at the end of line of the vehicle, where you heard about functions on demand, where a user or a dealer can enable new functions or activate, deactivate those functions. So here again, we see the software, this life cycle, and it's a matter not only during development, it's after the software, the start of production or the start of the deployment of the software. And to enable such mechanism, we need new, it's an infrastructure, what we call software update management systems, where the requests can come from multiple sources. So this can come from the OEM and offline. And here you imagine thousands of cars produced where there is a request to enable for a specific car different configurations, different functions to be activated. It can come at the maintenance or at the dealer shop, or it can come directly from connected cars to enable or to request. And this will be translated to transactions that will go to a kind of platform or an OEM portal. And the complexity here is that it's not just a matter of software, because the software that will be activated is coming from a supplier of supplier, etc. And this leads again to implement specific exchange model, to implement specific APIs that will impact all those stakeholders to achieve this mission. So this is why we need a common information exchange end-to-end. And of course, this will be translated by a need for a common and standard APIs. So as a conclusion, so the software product or the SWaP challenges are not limited to only the in-vehicle software. So it's a matter of the software factory to develop, to deploy the software. It's a matter of infrastructure. So software is becoming a product with technical and non-technical challenges. Decreasing the software complexity requires end-to-end solution for both development and operation. Because we hear a lot about increasing complexity, but there is a big focus, which is important for the in-vehicle software. Missing common and interoperable standard specification with ready implementation will introduce more challenges, because as you have seen, each time we have a need, so there is development of specific solutions. And of course, the strong collaboration is needed between existing consortium, because this message is not addressed only to AUTOSAR, because AUTOSAR perimeter is not only to solve this, because we have seen new initiatives targeting to enlarge and to cover the new SDV needs. So this is why this strong collaboration is encouraged, and I believe it will help to provide an efficient and holistic solution. So thank you for attention.